This conference will now be recorded.
This is Big Data with GenAI. So, friends, in the last session, we were discussing about the attention mechanism, and from the attention mechanism, what we were able to see, there are three main metrics: Curie matrix, then we are having key matrix, and value matrix. Okay, so what exactly is being happening with the help of these three matrix? Curie matrix is going to ask the question. The key matrix is providing the answer to that particular question, and value matrix is going to provide the information that what should be added in the embeddings to get the desired outcome or to get the context rich embeddings. Okay, ask the question. Let me write it. Ask the question, answer to the question. This matrix is responsible for answering to the question, and value matrix, what should be added in matrix in embeddings to get the context rich embeddings. So you can take an example, say GenAI is changing the world, the world. Okay, so GenAI changing the world. Over here, say world is not there. This is say blank space, and based upon this particular line, we are trying to predict world. So until unless this particular token D is not having the context of entire stuff which is given prior to this, till then it will not be able to predict the next word. I will not be able to say that after the world will be the next keyword. I will never be able to predict the next word. So how it can be possible until unless the context of these particular tokens or context of these particular words is baked to this particular token. Okay, until unless, just focus over here, until unless the context of these particular tokens which are prior to this is baked, till then I will not be able to predict the next word. And these particular things are given by these three metrics, and once we have done the calculation, so it is contributing around 58 billion parameter. So 58 billion parameter, that is part of total 175 billion parameter in GPT-3 meters in GPT-3. Okay, GPT-3. We were talking about the GPT-3 model. Okay, now that is perfectly fine now. So things are moving in this particular way. We are having a sentence. Okay, sentence, then sentence is converted into tokens. Tokens are converted into token ID. Okay, token ID, and then we are having embeddings. Embeddings that will be clubbed with positional encoding. After this, we are having attention mechanism. Okay, and then we are having MLP. So attention and MLP, these are the, you can say, neural networks, and over here multiple layers are there. You We have seen, like it will be say attention to MLP, then it will back to the attention mechanism, then MLP will come. So multiple layers will be there. Attention, then MLP. MLP. So multiple layers will be there, and uh, by passing these particular tokens from these particular layers, what we will get, the output that is having context rich meaning with the knowledge of outside world. Okay, MLP is going to add the knowledge from outside world, that is multi-layer perceptron. And then from this we will get the logits. Okay, and logits are given to the softmax function, and softmax function will convert into probabilities. Okay, so this is the entire stuff what is being happening inside the transformer architecture. So we have gone through with this particular architecture up to the attention mechanism, and up to attention mechanism what we are having, almost say 59 billion parameters are there up to this particular stuff or step basically. And these 59 billion parameters are the part of 175 billion parameters. So 58 is around one third of 175 billion parameter. Rest two-third are from the MLP, and let's have the discussion on to the MLP. So in today's session, our main agenda will be to have the discussion on to the MLP, multi-layer perceptron. MLP, multi-layer perceptron. What is the main function? To add the knowledge from outside world. Okay, so to add the knowledge, and one more thing, inside this attention mechanism, tokens are talking to each other in order to get the context rich meaning. Okay, in attention, in attention, tokens are talking to each other to get the context rich meaning. Embeddings basically. To get the context rich embeddings. But in MLP, friends, the tokens are not talking to each other. The tokens are not talking to each other. And this is very important thing. The tokens are not talking to each other in MLP. Okay. Now, now I'm giving certain examples, and let me copy these examples from the presentation. Okay. So over here, I'm having certain sentences. The Eiffel Tower is taller than the Qutub Minar. Okay. The second sentence, Elon Musk founded SpaceX in 2002. Python is a Python is both a programming language and a snake. Okay, the capital of Australia is Canberra. Okay, so over here, if I'm going to provide you these particular tokens or this particular sentence, and I just want to predict what will come next. Okay, Eiffel Tower. The Eiffel Tower is taller than the, and I just need to predict what will come here. If I am giving Elon Musk founded SpaceX in and blank, then what will be the output? So over here, is there any information about Qutub Minar in these tokens? Guys, be interactive at this moment. Huh? So are you able to get the information about Qutub Minar over here? Is something there related to Qutub Minar in this particular sentence?
No, sir.
No, definitely, like related to Qutub Minar, nothing is there. But the model is able to fetch the information. Okay, the model is fetch the information. I have not given 2002, but the model is able to get the information about this particular SpaceX, and definitely it must be available somewhere inside the storage or memory. Okay, from where it is referring to this information and it is able to fetch. Okay, so that's what we need to learn in this particular session, huh? Okay, so if we are talking about the MLP, that is nothing but to add the knowledge from outside world. But what exactly it is able to do with the help of what? Okay, so it is a stack of fully connected fully connected neural net layers, huh? Okay, so stack of fully connected neural layers where this particular information is stored, huh? And what how the model pre-training is being happening. So the data from the internet, from the wikis, from the organization, from sensors, a lot of data is picked, and then the pre-training process will start. And after that particular pre-training phase, the entire information is, you can say, clubbed inside these stack of neural layers, and from there it is going to utilize in order to get the or in order to predict the next word, huh? Okay, so we will see. So it is a stack of fully connected neural layers, and that will transform the embeddings into the knowledge, huh? And it will transform the knowledge or embeddings into knowledge, huh? Okay, it will transform the knowledge into transfer the embedding into knowledge, huh? Okay, so that is the usage of MLP. Now how this particular process will happen? Okay, in order to get this, in order to get the knowledge, or in order to bake knowledge into embeddings, what we need to do, we need to multiply the embeddings. Okay, we need to multiply the embeddings by a matrix R. Okay, in order to get the knowledge from embeddings, we need to multiply embedding, say E1 or E, with a matrix R. Okay, with the matrix R. So R is the matrix, and this is the size of this matrix, huh? This is of 49152 cross 12288, huh? So this is the size of this particular matrix, huh? 49152. And from where we get this matrix? It comes from pre-training phase only. Okay, so it is coming from the pre-training phase only. This particular matrix is coming from the pre-training phase only. So if we are now what we need to do, say this is the matrix and R multiply with E, that is like the tokens. These are nothing but the tokens. So each and every token, say FL is multiplied with this particular matrix, tower will be multiplied with this particular matrix, taller will be multiplied. So each and every token will be multiplied with the matrix in order to get the information. Okay, so R multiply by E. So thus, what is the size of E? What is the size of E? Guys, what is the size of E? Each token, and how many dimensions are there in GPT-3? We are talking, we are going to multiply each token, and each token will be having how many values or floating points? Mm-hmm. How many features are there in GPT-3? Guys, Shivam, Vijay, Vikas, Tejas, Gurmeet, Vranch. How many features are there?
So it's 12288.
Yes, 12288. So 12288 are the features for each token. So cross 1. Okay. So each token will be having these many features, and I just want to get the embeddings by multiplying with this particular matrix R. So what will be the output? The output will be 49152 cross 1. Okay, like you can say that initially I was having 12288.
What is 4952?
Come again.
Hello. What is 49152?
49152, this is a 49152 cross 12288. This is a matrix which is coming from the pre-training phase. Or you can think in this way, like the researchers have identified 12288 multiply by, you can say, 4. Okay, it will be equal to 49152. Okay, in order to convert the features from lower dimension to higher dimension. So 12288 is the lower dimension, and we are converting it to the higher dimension, 49152. Fine.
Okay, okay, fine.
Okay, so it is almost it is 4 times, and this has been picked from the researcher. Okay, like this will be the matrix size R, and it will come from the pre-training phase, and it will be multiplied by the token, and then we will be getting the matrix of 49152 cross 1. So for, you can think in this particular way. Previously, say Ln is a token. Okay, and for Ln I was having 1 2 3, and it is up to 12288. These were the values initially. Yeah, now what has been done after, you can say, converting it to the higher dimension, the ln will be having, say, ln, and 1 2 and 3, and it will be up to 49152. Okay, so I will be having this much of the values. You can think in this particular way. I have converted the features from lower dimension to higher dimension, right? Are you able to get? All of you?
Yes, yes, yes.
Okay, this is the simple multiplication. Okay, we are having the matrix of this size, and we are going to multiply it with this, so definitely the outcome will what it will be 49152. The basic thumb rule, those who are not able to get the information like how the matrix multiplication is being happening, so the base, in order to have the multiplication of two matrix, like the inner part must be the same. The inner part, like 12288 is there, and over here the 12288. So if these two are matching, then we will be able to have the multiplication of these two matrix, and the output, what it will be like the initial one and the last one. This Okay, now we are able to get the higher order matrix, uh, or like higher size of embeddings with respect to the each and every token. Once we are able to get this particular embedding, then what will happen? The output, say, it will be like this. It might be possible like we are having certain values with minus, okay, minus 2, 0.2. Okay, these are nothing but the floating point numbers, and say 3.4. You can think in this particular way. Okay, so after having this particular matrix multiplication, if like the values are in minus, then those particular values are or you can say converted to zero. Okay, and these value, the conversion is done with the help of one function, that is relu. Okay, so relu function is being applied onto the output which we got from the matrix multiplication. And what this relu function will do, this relu function will convert the values which are having you can the values with minus will be converted to zero. So it will be like this. It will be relu. What it will do, it will convert the values or negative values to 0. Okay, so relu function will convert the negative values to 0. Okay, now the output will be like this. Okay. Okay, so 0, if we're talking about the neurons. Okay, so neurons, now this is nothing but the output from what we will get from the relu function, and it's specifying that we are having the 0. Okay, 0, what it means, like we are having 0 means like the inactive neurons, and values positive higher value, that is nothing but active neurons. Okay, active neurons. What is the meaning of this? Like the values which are having higher numbers or positive higher numbers are considered for the further calculation, and the inactive neurons or the values which are having 0, those particular values will not be considered for the next step. You can take it from this particular diagram. Okay, now this is nothing but the example of neural network. Okay, this is the example of neural network, and say we are having we are onto this particular phase, the second phase, second stage, or we are onto the second stage. We have done the calculation we have done the matrix multiplication. Now we got some values with positive higher number. So higher number, that means the significance is there, the value is related to the tokens are having the relevance, okay. And if the tokens are having relevance, then the output will be positive higher number. If that is there, that particular value will be considered for the next step. In this particular way, like, we will be having the multiple hidden layers, and the positive higher number will be considered for the next move. Just have a look over here. The output of R and E matrix will be this one, and we can have the negative values, we can have the positive values, and the negative values are converted into 0, and that is done with the help of ReLU function. That is perfectly fine. Now what is happening, if we are talking about the matrix R? So what exactly is being happening over here? So over here, like, it is specifying, like, say certain questions are being asked. Okay, certain questions are being asked, like, say the Eiffel Tower is, we are having like lots of information that is there inside the stacks of neurons. Okay, and this information will be like this. The Eiffel Tower is taller than the Statue of Liberty. Eiffel Tower is taller than the Leaning Tower of Pisa. Eiffel Tower is taller than the Big Ben. Eiffel Tower is taller than the Qutub Minar. Okay, Eiffel Tower is taller than the Great Pyramid of Giza. So this particular information is there inside the stacks of neurons. This particular information is available. Now this particular information, okay, what is available inside the stacks of neuron, okay, and it will be multiplied with the output that we got after the multiplication of R and E. Okay, so what we have done so far, just have a look over here. So we have done the matrix multiplication R and E. This matrix multiplication is done, okay, and we got the output as say O, okay, and that is the matrix of this particular size. Okay, that is the matrix of this particular size. Now this particular matrix is passed from the ReLU function, okay, and then whatever the output, say O dash O1 is the output at this moment. So this particular output, which is having active and inactive neurons, this particular O1 matrix is multiplied by the another matrix, that is, you can say, downward projection matrix. Okay, so we have seen R, that is of size 492 into 12288, and say R1 is there, R1, that is the another matrix which also come from the learning pre-training phase. Okay, and the size for this is 12288. 12288 cross 4915. So this is the size. Okay, and what exactly is there in R and R1? So over here we will be having the stack of, you can say, knowledge. Over here, let me write it in R and R1 matrix. The knowledge is available is available and it came from the pre-training phase. Okay, it came from the pre-training phase. So R and R1, these are the two matrix. Initially what we have done, we have multiplied the embeddings with E, embeddings with R matrix, and we got the O1 after passing it from the ReLU function and all. And these are nothing but the collection of active and inactive neurons. These active and inactive neurons will be further multiplied by this particular matrix, and this matrix is nothing but the combination of, you can say, the knowledge available, and that is coming from the pre-training phase. You can think in this particular way. uh, Over here, 1 2 3 and up to 4 9, just have a look over here, guys. Just focus. So what I have mentioned, 1 2 3 and up to 4 9 1 5 2, this is nothing but the number of, you can say, columns. And these columns, say the first column is with respect to the Eiffel Tower is taller than the Statue of Liberty. This is the first one. The second one is with respect to the Eiffel Tower is taller than the Leaning Tower of Pisa. Okay, so with respect to, say, each and every column, we will be having certain information, and for each and every information, we will be having this much of floating point numbers. Okay, now this information, what is available? Okay, this information which is available in terms of the rows and columns, or in terms of matrix, it will be multiplied, or we will be having the dot product of this information. What the output, what we will got, what we got from the previous step. So previous step is having the active and inactive neurons. Now once the matrix multiplication, say this say this particular token will be multiplied by this one, this particular this particular, you can say, vector will be multiplied by this one, this particular vector will be multiplied by this one. So if, say, this over here, say if you can say A13, okay, that is multiplied by a you can say 3 3 1. Okay, so the output, what it will be, it will be 0. So this particular, you can say, value will not be considered. Okay, the value will not be considered for the further step. And this is the way, like how we are removing certain values from the matrix multiplication. So in each and every step, like in this will go from the multiple phases, and from each and every phase the informations are fine tuned, and at the end we will be able to get the fine tuned, or you can say the context rich embeddings or output with the knowledge. Okay, so we will pass it from the multiple neurons. And over here, if we are talking about the MLP, or if we are talking about the the GPT-3, there are 96 phases, or 96 steps, basically what I can say. Layers, basically. So in GPT-3 there are 96 layers, and once the tokens embeddings are passed from each layer, passed from one layer to another layer, or passed from one layer to another layer, then the embeddings will be fine tuned in order to have best knowledge from the stacks of neurons. Okay, you can take it in this particular way, like we are having r that is multiplied by e1 e. Okay, we got o, it will be then passed to from the ReLU. Okay, and ReLU will be multiplied with say r1, and what we got, say output, say O2. Okay, now this particular step will be keep on happening. Okay, it will pass from one layer to another layer, and we will be having, say this is one layer, this is layer one. Okay, so this is layer one, and in the same fashion we will be having the 96 layers. And when once we are passing the you can say embeddings from these particular layers, in the response we will get the tokens with the best knowledge from the stacks of neurons. Okay, so that is like what is happening inside the MLP. And if we are talking about the matrix, so we are having this particular matrix, that is the R matrix, say. Okay, and if we are having this matrix, the total parameter, if you multiply it, is around 600 million. And we are having R, say one matrix as well, and that is having the size of what, size of 12288 cross 49152. Okay, so that is almost say 600 million parameter, and if we add, it will be around 1.2 billion parameter. And we are having 96 layers, this is with respect to layer 1. And if we are having 96 layers, then it will comes around 116 billion parameters. Okay, 116 billion parameter. So 116 billion parameters are coming from the MLP layer. Okay, and over here, once like we are having this particular matrix, say R1, it will be multiplied by this particular matrix. Okay, and in the response, what we will get, like 12,000 cross one. Okay, so you can say this is the downward projection matrix, and the initial R is nothing but the upward projection, it is changing the projection. So previously we were having, you can think, once we have taken the upward projection matrix, so 12288 features are converted to 49152. Once we have taken the downward projection matrix R1, which is having this particular size, it is multiplied with the output of ReLU. Okay, and in the response we get 12288 cross 1 value. Okay, so that is nothing but the downward projection matrix. Okay, because we are having the lower dimension. Previously it was 49152, now it becomes 12288. So this is nothing. R1 is the downward projection matrix, R is the upward projection matrix. And after passing the embeddings from these 96 layers, we will get the best knowledge. The knowledge is baked into the embeddings, and we will be able to predict the next word. Okay, so that is coming from the stacks of neurons. And the R and R1 matrix, this is cumulatively contributing 1.2 billion parameter. We are having 96 layers. 96 layers are contributing 116 billion parameter in total. So what I can say at this moment, like we are having pre-training phase, pre-processing, what I can say, pre-processing, not pre-training. Then we are having attention mechanism. Then we are having MLP, okay, and then we are having post processing. Post processing, okay. Pre processing contributing to say 600 million parameter, 617 billion parameter, okay. Attention is contributing to 58 billion parameter. This ML phase is contributing to 116 billion parameter, and uh, post processing, that is nothing but like we are going to multiply uh, these particular, you can say, output with the unembedding matrix and all, okay. Or unembedding, what I can say, pre-processing. Inside the pre-processing phase, what we are having embedding and unembedding matrix. So I can add both of these two over here only. 617 billion, you can take it in this particular way, okay. 617 million parameter. 58 is from the attention. Post processing is nothing but softmax is done over here, okay. Softmax, okay. So in total 1.2 billion. So 1.2 billion, 58 billion, and 116 billion. So it will be around 1.175 billion parameter. 58 plus 116. It will be roughly around 175 billion parameters. So this much of parameters are there inside the GPT-3 model, and this is the way like how the calculations are being happening. Now, what I can say, pre-processing, this is contributing to this much of parameter. Attention mechanism is contributing to this much of parameter. MLP layer, that is 116 billion, and in the post processing we are moving with the softmax and all, okay. So in total we are having 175 billion parameter now. So whatever we have discussed, that is, you can say, the tougher part from the GenAI perspective. Tougher part in what sense? Because these are the basics, and uh, we we can skip this particular stuff, but in order to get the deeper understanding about this particular Gen AI stuff, so these things are important, okay. In order to get the understanding like how the things are happening internally, okay, I can just say MLP is going to take the knowledge from the outside world, okay, that is stored inside the stack. But how this knowledge is, how we are able to take this particular knowledge, we are having nothing but the simple maths, and with the help of matrix multiplication and all, we are able to get that particular information. What attention is doing, what are the different things, what are the different, you can say, matrix inside the attention mechanism, based upon what we are able to get the context rich meaning. So that is like something we should learn. And if you are able to get the 60 to 70% knowledge, then that is more than enough, you can go with the recordings again and again in order to get the more context. But in upcoming sessions we will be having more focus towards the practicals. The major theoretical part is over, okay. Now we will be having focus towards practical only, yeah. So these things are important, I think. What I can say, I can resume the session, I can, you can say, conclude the session over here only, and we'll resume it onto the next week, and then we will be having the focus onto the practical part, so that's it from today's session. If you are having any doubt, you can ask,
So this 96 in the GPT-3, it's the neural layer, all neural layer which is present in GPT-3.
Yes, these are the neural layers.
Okay, so it is accurate means in any model, GenAI model, or it is keep changing.
No, it will keep changing.
Okay, for every model.
Yes, 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 yes.
Okay, got it.
Anything else? Anyone having any doubt? Shivam, Vijay, Gurmeet. Okay, fine. Then we can conclude the session. Thank you.
Okay, sir. Thank